I want to find the equation of each line in gradient-intercept form. Well, in part A, we're given the gradient and we're given the y-intercept. So straight away we can write y is negative 2x, so the gradient times x, and then the y-coordinate of the intercept is positive 5. We now have a line of gradient 5 passing through this point. Now we can use y take away y1 is mx minus x1, which is my favourite way of doing this type of question. Now in this, the coordinate is x1 and y1. So we have y take away 3, m is the gradient, so that's 5, x take away negative 2, which will end up being plus 2. So y minus 3 is equal to 5x plus 10, and then y is going to be 5x plus 13. Now part C is just very, very similar. So it's just here to show you the advantage of using this particular formula. If you just use y equals mx plus c, it becomes quite awkward when you're working with fractions. Once again, this is x1 and y1, the point we actually know. So not y equals, but y take away a half is going to be equal to negative 2/3 x take away 2. So y take away a half is going to be negative 2/3 x plus 4/3. So y is going to be negative 2/3 x, add 4/3, add a half when we bring the half over. So y is going to be negative 2/3 x plus 8/6, add 3/6. So we get y is negative 2/3 x plus 11/6. And finally, we want to go through these 2 points. So the first thing we need is the gradient. So let's call this one x1, y1, and this one x2, y2, although it doesn't matter which is which. And the gradient we can find using y2 minus y1 over x2 minus x1, difference in the y's over difference in the x's. So that's going to be 5 take away negative 1 all over 1 take away negative 2. So that gives us 6/3, which is 2. So we know the gradient is 2. And then I could use either point in y minus y1 equals mx minus x1. In other words, I could make this one x1, y1. In fact, let's do that. They're both positive numbers. It makes it easier. So the y would be 5 there. The m we've just found is 2. And x take away 1. So y minus 5 is going to be 2x take away 2. So y is going to be 2x plus 3.